Hello, so today we are going to do a little bit of an explanation for sweep line algorithm. This algorithm comes up a lot in competitive programming and in LeetCode, so a quick overview for it today. So what this algorithm is for is basically a set of events that are processed in a sorted order, right? So a set of events in sorted order. So this can be something like customers arriving at the restaurant, right? They arrive at separate times. It can be intervals in a calendar, so a meeting that has a start and end time, and then you have another follow-up meeting, and they may overlap as well. So for our first example here, just to get an idea of what kind of problems we are dealing with, let's take a restaurant, and we have customers that arrive at a certain time. So there is like a arrival, and we have a leaving time. And let's say, for example, for each customer, we know the arrival and leaving time. And here, for one customer A, they arrive here and they leave here. B, they arrive here, leave here, and we continue like this, right? So I'm presenting them here as intervals for the time they spend at the restaurant. And one question we can have is, what's the maximum number of customers who were at the restaurant at the same time, right? How can we solve this? So you can see here, if we draw a line here, this is the maximum one. Here, for example, just 2. Here we have just 1. Here we have just 2. But here we have 3. All A, B, customer A, B, and D are at the restaurant, right? So here we have A, B, D at the restaurant. So how do we solve this with line sweep? So you can see here, just from the first line I drew, that we can just do this. So have a line like this and just keep progressing. And each time check how many intervals we have. Now the question becomes, how do we know how many intervals that line intersect with at a specific time? Well, what we can do is just at the beginning of the interval, so at the arrival time, we can increase by 1. And then at end time, we can decrease by 1, right? So what this would mean is that this is arrival time, so increase by 1. This is arrival time, so we add 1. This is arrival time, add 1. Leaving time, we need to decrease 1 because at this moment here, right, we used to have 2, right? But when we are here, we need to decrement by 1 because this customer just left. They are no longer at the restaurant. So for counting the number of customers at the restaurant, we need to decrease by 1 at the leaving time, right? So let me just... that's what we can do here. So at the end, we decrement by 1. And then at the beginning, we increment by 1. So definitely the first step is recording these events, right? So we need to have an event for the time and what is the event. So what this would be look like something like, let's say for example, we have a list of restaurant that has the, of customers that has the arrival and leaving time. So that may be like, let's say 1, 2, 3, 4, 2, 5, and you get the idea, something like this. So what we want to record in the events, as we said here, is the arrival and leaving time. So that would be the arrival time. Here, for example, it would be 1, and we have 1. And for this one, it would be 1, and we have -1. Sorry, 2 and -1. For the second one, we'd have 3, 1, 4, -1, because it's the ending time, and you get the idea here. And the other thing is we need to sort them. You can see here the line sweep I did. We need them to be in sorted order, right? So that we can add, when we add, we know exactly at that time how many customers are there. So we need to sort the events. Right? And what we want is we want to sort by the time here, right? And one problem though is, what if we have let's say one that adds at 3 and ends at maybe 3, right? Then we would have 3, 1, and 3 minus 1. And so with the sorting order, the end time would be first, right? And so depending on your problem, you may want to add different values. So you may want, so that the sort, or if you want the start to always be first, you may maybe choose to have here +1 and have here, or have here -1 and have here maybe +1, and then check if this value here is equal to -1, add 1 to the count. If it's here, decrement 1. So you need to play with it depending on what the sort order you want. Or the other alternative is also to do something like here, to do it by key and make sure the key is only the first element, right? When you are sorting. Okay, so now to solve our solution, which is the maximum number of customers, well, what we can do is just go through the events, but keep track of like the current customers count at the restaurant. Okay, maybe we can just abbreviate it to current, right? And what we do is we go through the events, so we'd have the time after sorting them, and then we'd have the count, or the delta, let's call it, which is +1 at the start and -1 when they are leaving, right? And each time we want to just add that value. If it's of course, this is if we are having +1 or -1, because when we arrive, we increment the number of customers. When we leave, we decrement. And since we want the max of number of customers, we want here to get the max, so that would be equal to the max of whatever current we have. And this will end up actually being just taking this, right? It will end up being here, current is equal to 1, so we update our max to 1. Here, the current will be equal to 2 because we add this one, and so we update our max to 2. Here, current will be equal to 3 because we add 1 here, so it will be equal to 3, and so our max will be updated to 3, which is the right solution. Once we get here, we will decrement 1 for current, and so now at here, our current is equal to 2, and we check if it's the max. No, that's smaller than the max, so we don't update, and we keep going until we reach the last one here. And we do this in sorted order because we sorted the events. In terms of time complexity for this algorithm, the most expensive operation we do is this sort here, right? We already did, we do one loop, which is O(n), but we also do this sort, and this sort here is O(n) log(n), n being the number of customers, like a number of arrivals plus the number of ending, right? So it's roughly 2n, n being the number of customers. So, but we can just summarize that as O(n) log(n). And here this is O(n), so overall the time complexity is actually this, right? Because it's the bigger portion. Yeah, and then of course here we return the max we find, and that's pretty much it. So yeah, this is roughly the general idea of Sweepline, assigning values to the events as events, and then sorting them, and then doing some processing to find the information you are looking for. Yeah, and there are a lot of examples. I can add a couple of problems in the description so that you can practice on, but this is the idea. Yeah, so that's pretty much it. Thanks for watching, and see you on the next one. Bye.